Welcome to Project 2.4 Unpacked, the 555 timer. Today, we'll explore how op amps, NOR gates as SR latches, and a few other components work together in a circuit to produce a 555 timer, which creates a square wave and will even convert the output into a sine wave. This is the 555 timer build in astable mode, which is creating a square wave which is being visualized by the LED. The 555 is being fed by a 1 kilo ohm resistor, 100 kilo ohm resistor, and 1 microfarad capacitor. This is the unpacked 555. It uses an LM358, a 4001, and a 3904 NPN transistor to create a 555. This is a square wave to sine wave converter. It uses a series of low pass filters to filter out the harmonics from the square wave to produce a sine wave. An operational amplifier, or an op amp, is a voltage amplifier with two inputs, the inverting input and the non-inverting input. In this circuit, the op amp acts as a comparator. It compares the voltages from the two inputs and decides whether the output is going to be high or low. This is crucial for generating square waves in the 555. Next, we have the SR latch using the NOR gates. The latch has two inputs, set, reset with outputs Q and Q bar. When S is high, Q becomes high. When R is high, Q becomes low and Q bar becomes high. If both inputs are the same, the latch holds its previous state. Inside the 555 timer integrated circuit, 3 resistors divide the supply voltage into 1/3 and 2/3 VCC. Capacitor charges the resistors R1 and R2 until it reaches 2/3 of the VCC, triggering a discharge. When the voltage drops below 1/3 VCC, the charging resumes. This cycle repeats, generating an exponential wave. The exponential wave is fed into the unpacked 555, which converts it into the square wave. The frequency of the square wave is given by the formula 1.44 over R1 plus 2 times R2 times C. So when we input our values from this circuit, we get 1.44 over 10 to the power of 3 plus 2 times 10 to the power of 5 times 10 to the power of -3. So when we simplify this, we get 1.44 over 201, and we end up with 7.16 hertz. If you actually do the math for this, you'll notice that you end up with a decimal. But because hertz is 1,000 times per second, you have to multiply whatever your answer is by 1,000 to get the hertz value. Finally, let's move out the square wave. A square wave contains many sine wave harmonics. By passing it through 3 low-pass RC filters in series, we filter out the higher frequencies and leave the fundamental sine wave. For this circuit, we use 1K and 10 microfarad capacitor for our RC filters. More filters improve the sine wave quality, but reduce the output voltage. 3 filters strikes a good balance between these two. Thank you for watching.